how to solve trig functions, right? So how to solve trig functions. So take a look at this. I'm sorry, how to solve trig equations. So take a look at this first equation here. I want to solve this, okay? Now, whenever we solve any regular old equation, what is it that we're looking for? We're looking for all of the x values that I can plug into x over here, and it makes that equation true. What are all of the x values such that 3 times that number plus 6 equals 13? Okay, and we've done, you know exactly how to do that. So one way, by the way, to do that is to graph 3x plus 6, right? And see where, for what x value it equals 13, right? So here we're going to look at cosine of x equals a half. For what x values is cosine equal to a half? One way we can do that is graph cosine. So look, we've graphed cosine here. And this dashed red line is y equals a half. So look at all of the places where cosine is equal to a half. Right there at pi over 3. Is that right? Cosine of pi over 3 equals a half? Yeah. And right here, 5 pi over 3. Is that right? Cosine of 5 pi over 3 equals a half? Yes. And also at, here. And also here. And also here. So how many times in its lifetime will cosine equal to a half? Infinite number of times, right? But look, the first two instances that we see are x equals pi over 3 and x equals 5 pi over 3. Now, from that pi over 3, if I go over a distance of 2 pi, cosine is half again, correct? And if I go a distance of 2 pi this way, cosine is a half again. So every 2 pi, so one way I can write that is pi over 3 plus 2 pi, pi over 3 plus 2 pi times 2, pi over 3 plus 2 pi times 3, or pi over 3 plus 2 pi n, right? When I go n pi over, n times 2 pi over. Same with 5 pi over 3. I can go over 2 pi, or I can go over 2 pi this way. And so 5 pi over 3 plus 2 pi n is all of the points where cosine is a half. Now, we're not going to do minus 2 pi n because n could either be plus 1, 2, 3, 4 or minus 1, 2, 3, 4. Okay? All right. So, in one, hang on. So in one rotation of the unit circle, right? Cosine is 1/2 at what and what? At 2 points, pi over 3 and 5 pi over 3. Okay? But then if I go from negative infinity to positive infinity, if I go over the entire domain, then x is equal to pi over 3 plus 2n pi. X is equal to 5 pi over 3 plus 2n pi. So if I only want to know the answers in one cycle of the unit circle, cosine is equal to a half where? At pi over 3 and at where? 5 pi over 3 right here. Right? Because it's negative here and here. But if I want to talk about over all x values, then it's pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n. Okay? All right. So let's solve this equation here. Yep.
So we would, like for the graph, we would look at the first two positive.
Yeah. We're generally not going to do it from the graph, though. We're just going to do it using the equation. So take a look at how we're going to do this. To solve these, first you want to isolate the trig function. So here I have sine x is everywhere, so I could just do minus 2 sine x minus 2 sine x, and I get 2 sine x equal to root 2. Divide by 2, divide by 2. Now, my equation is sine of x is equal to root 2 over 2, which you know in your mind, root 2 over 2 is the same as 1 over root 2, right? So, I ask myself, on the unit circle, where is sine of x equal to 1 over root 2 or root 2 over 2? At pi over 4 and 3 pi over 4 here, right? Because sine is positive here, it's negative in the other quadrants. It'll be negative 1 over root 2 in the other quadrants, okay? So, x is pi over 4, but now look, not just pi over 4. Every time I go back there, plus 2 pi n. And then x is 3 pi over 4 plus 2 pi n. And that's the answer. Okay, one thing, I have 2n pi up there, but I have 2 pi n over here. It really doesn't matter where you put the n, okay? All right, yes.
Oh, what's it called? So, do we always find like where it's sine or
Yeah.
cosine or whatever
Yeah.
we're given? Do we always find wherever it's positive and then we use wherever it's
You
positive?
find whatever this is. Where is sine of x? If it's positive,
But
positive. If it's
sometimes it
negative.
can be like negative.
Right. Let's do a couple of equations and then you'll see. Okay, let's do a couple and then you guys will see all the different situations. So take a look at this one. Minus 4 minus 4. 3 cotangent squared x is equal to 3. Divide by 3, divide by 3. Now I have cotangent squared x is equal to 1. Now, that's cotangent squared. So I want to take a square root, and I get that cotangent x is plus or minus 1. Don't forget the plus or minus. So now I have two equations. I'm asking myself, where is cotangent equal to positive 1? Where is cotangent equal to negative 1? On the unit circle, cotangent or tangent is equal to positive 1 here and here, right? At pi over 4 and 5 pi over 4. Where is it equal to negative 1? Here. 3 pi over 4, 7 pi over 4. Okay. But now look. Instead of saying pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n, you basically want to find a pattern in how often this answer repeats. When I'm going exactly. When I'm going along the unit circle, I can go from one solution to another solution in 90 degrees time, or pi over 2 time. Then I can hit another solution in another pi over 2, and another solution in another pi over 2, and another one in another pi over 2, and so on and so on and so on. So what I say is x is pi over 4 plus pi over 2n, right? So before, there wasn't such a pattern. I couldn't have like a regular pattern in going from the pi over 4 to 3 pi over 4 and then back to this. But when they are at equal intervals, then I can do that. And it only happens... Well, okay, so you have to kind of look at where your answers end up. This either happens if you have like 4 equal ones, like all of the pi over 4s, and they're like at every 90 degrees. Another situation where it could happen is if there are 2 answers on a 180 degree line. Okay? We'll come across those as well. Okay. Yep. Plus pi n. Yep.
So wouldn't the answer be the same if it was tangent?
Yes, it would be the same if it was tangent. Facts. Yep, good. Because tangent is also the same values on those points. Tangent of pi over 4 is also 1. Okay, good. So Here, okay, so take a look at what this says. Find the solutions of the equations over the interval 0 to 2 pi. This means we're only going from 0 to 2 pi. That means it's only one cycle around the unit circle, so you don't need the 2 pi n. Okay? You only want whatever shows up one time on the unit circle. Okay. Now, for this, how do you propose we solve this? Yep. Okay. That is always the first instinct, right? Is divide by sine x, which definitely will get us to a solution, but it only get us to half of the solution, because what we'll be doing then is we will erase any records of the sine x. So you're kind of getting rid of information. Instead, what we do is just like any other equation, take everything to the same side and factor. Okay? So bring this to this side, so I get 2 sine x cosine x minus root 3 sine x equal to 0. And now we're going to factor a sine x out. So factor out sine x, just like we did in yesterday's homework. So let's remind ourselves. When you factor anything out of an equation, let me actually write it closer here. When you factor anything out of an equation, it's like you're mentally dividing each term by the thing you factored out, right? So if I factor out a sine x from this term, it's like I divide by a sine x and I only have 2 cosine x left. Minus, what do I have left from the other one? Root 3. Okay, now take a look at what we have. I now have two terms, I now have two things that are multiplying to 0. Only when you have something times something equal to 0 can you set each one of them equal to 0 separately, right? This is the zero product property. You have a product of things that make 0. Only then can you do this. So now we're going to say sine x equals 0. 2 cosine x minus root 3 equals 0. Okay, so where is sine x equal to 0 on the unit circle? 0 and pi. So x is 0, x is pi. Here, add root 3 to both sides. 2 cosine x equals root 3. Cosine x equals root 3 over 2. Where is cosine equal to root 3 over 2? Pi over 6 and where is it positive? It's positive here. So 11 pi over 6. Okay, so x is pi over 6, 11 pi over 6. Now you have to write out all 4 of these answers. And usually, it's not a deal breaker, but usually we write them in like increasing order, right? So 0, pi over 6, pi, 11 pi over 6. Now on the test, if you only write 2 of the 4, not full credit. 3 of the 4, not full credit. If you write all 4 in different order, obviously full credit, okay? Yeah, I mean, you don't have to like put it in, but the book will always put it in this order. Okay? Do you see this now? Like, okay, do you see why starting last year, I was always like, you gotta know the unit circle. And if you're drawing the unit circle every single time, it's just wasting a lot of time. So you gotta visualize. Yep.
I don't get why it's 0 and pi.
So here, where is sine of x equal to 0? Sine is the y value. It's 0 at 0 and pi. Right? Because, right? This quadrant, this is negative 1 comma 0. This is 1 comma 0, and the y values are zeros there. Okay? Okay. Huh?
I forgot to reuse like the size stuff.
Okay. Let me tell you the most common mistake that students make. Okay, ready? They'll have some sort of thing equal to like 1 or equal to 2. Two things multiplied equal to 2, and then they'll say sine of x equals to 2, cosine of equals to 2. Can't do that. You can only do that if this equals 0. Okay? Yeah. Huh? Oh, yeah. So look at this. This says 2 pi with a parenthesis. That means you don't have to include 2 pi. Yeah, 0 is there, but 2 pi isn't. Let me, okay. So I actually, one thing I forgot is about that notation. So when you have this notation here, this means like this. So when you have the bracket, it includes the 0. When you have the parentheses, it doesn't include this. Okay? Yeah, that's something I should have told you guys before, but next class I'll go over it with everybody. So this is notation. In like pre-calc and calc, we use this. And so when this is saying go from 0 to 2 pi. This is the exact same thing as writing this. But when you have a bracket, it's like less than or equal to. When you have a parenthesis, it's just less than like this. Okay, let's take a look at this one. First thing we're going to do is move everything equal to the other side and set it equal to 0. Okay, so let's move everything here. Now, how many terms do we have here? 4. Whenever you have 4 terms, you factor by grouping. Okay. Factor by grouping. So here's what we're going to do. We're going to split this down the middle. From the left-hand side, what can we factor out? 2 cosine x. And I get 2 cosine x plus 1. And then from here, what can I factor out? Minus root 2. And I get 2 cosine x plus 1. Oh my God. Same thing. So now remember, factor by grouping, you're always going to have an item that's the same. Write that item off to the side one time. And then what do I have left? 2 cosine x minus root 2 equal to 0. Now look, one thing times another thing equals 0. Okay? So now split it down the middle. 2 cosine x plus 1 equals 0. Yep. So here, how much is cosine x equal to? Negative 1/2. Okay, so on the unit circle, where is cosine equal to negative 1/2? At 2 pi over 3 and? 4 pi over 3. So x is 2 pi over 3, 4 pi over 3. Now, next one. 2 cosine x equals root 2. Cosine x is root 2 over 2. Those are the pi over 4s, right? So it's pi over 4 and what else?
And
7 pi over 4. 1 under 8 pi. So 1 pi, 3 pi, 5 pi over 4, 7 pi over 4. Yeah, here. So the answers then are going to be pi over 4, 2 pi over 3, 4 pi over 3, 7 pi over 4. No, because it's still like within 0 to 2 pi. Okay? Now,
Not to go in order.
I mean, I like to, again, not a deal breaker, but once you have it on the unit circle, you could just like go in order. Okay, so you can also use trig identities to solve these. That's why we did section 1, okay? So find all solutions on the interval 0 to 2 pi. So take a look at what we have here. We have a cosine in conjunction with a sine squared. In this case, moving the sine to the other side and like factoring that, that's not going to work like it did for this first one here, okay? Also, when you have a cosine and then a sine squared, that kind of tells you, you know what, maybe I can use a Pythagorean identity and then I'll have everything in terms of cosines, right? So what is a Pythagorean identity that connects sine and cosine? Let's see. So we have sine squared x plus cosine squared x equal to 1. So what I want to do is I want to replace that sine squared x. If I rearrange this identity, subtract cosine squared x from both sides, look at what I get. Sine squared x is equal to 1 minus cosine squared x. Hang on, stay with me, you'll see what I'm doing. You'll see what I'm doing. So this is going to be 1 minus cosine x equal to 2 times, I don't have a problem with the 2, I just have a problem with the sine squared. 2 times sine squared. What is sine squared? 1 minus cosine squared x. Okay? Now, do you see what this did? Now everything is homogeneously in terms of cosine, and I can work easier with that. So let's see what's going to happen here. I'm going to distribute the 2. 1 minus cosine x is equal to 2 minus 2 cosine squared x. Here is where students do all sorts of things. Remember, set everything to 0 and start from there. Set everything to 0 and start from there. So let's move everything to the other side, right? So minus 2, minus 2. And then I'm going to also bring the 2 cosine squared to the other side, okay? So I'm going to have 2 cosine squared x minus cosine x minus 3 equal to 0. Oh, minus 1. Sorry, minus 1 equal to 0. Okay, let me write that cleaner. Who said quadratic equation? Did you say quadratic equation? That is a quadratic equation. Yay! Okay, we're not going to do that. Okay, please. Okay, so look. Okay, take a look. This has the same pattern as this. Do you guys see that? 2 something square minus something minus 1. So, how would we solve this one? It would be 2x and x. And here we have to get a 1 because that's the only way to get multiplied to 1. And then what would be plus and what would be minus? It would be plus 1 and minus 1. Okay? Same thing, but now x's are cosines. So this is going to be 2 cosine x plus 1 cosine x minus 1 equal to 0. Okay? So you know what? Let's see how we would have done that. Yep. So look. Equal to 0. I need a 2 cosine squared. 2 cosine x cosine x, right? That multiplies to cosine squared. Now, how can I get a minus 1? It's either plus 1 minus 1, minus 1 plus 1. So in this case, it's going to be plus 1 minus 1. Now, do I have two things that equal to 0 after they're being multiplied? Set each one equal to 0. So, 2 cosine x plus 1 equal to 0. Cosine x minus 1 equal to 0. So here cosine x equals negative a half. Where is cosine equal to negative a half? Here and here, right? So 2 pi over 3 and, right, 2 pi over 3, 4 pi over 3. Where is cosine equal here? What do we have? Cosine x equal to 1, just at pi over 2, right? It's negative 1 anywhere else. So my answers are pi over 2, 2 pi over 3, 4 pi over 3.
Why isn't it just the 2 cosine x plus 1 times cosine x?
Huh?
Why do you have to?
Because we want to solve for x.
Miss Lee,
Yeah.
cosine x equals 1, x equals 5. No,
Wait. No, wait. Where is cosine equal to 1?
0.
At 0. Oh my goodness. Yes, at 0. Okay, sorry. You know what? Hang on. I need to charge my computer because it's distracting me.
But you can write
That is-
0 even if you're given that like quantity, that's a 0 column.
Yes, because 0 is included. It's in the bracket. Good. Yep.
If it was parentheses and then bracket,
Yeah.
you wouldn't.
Correct.
Just write 2 pi.
Correct.
Alright, also can I ask a question?
Huh?
Can I ask a question?
Let me do one more.
Miss
Let's
Lee,
do
and
this one. Yep.
then for like the thing that you wrote on the top, like here,
Mhm.
that area, now we're supposed to memorize that like little.
Okay, let's do this one. How are we going to do this one? Minus 2. So we have cotangent squared x, cosecant squared x, 2 cosecant squared x, minus cotangent squared x, minus 2 equal to 0. Okay, now what do? We've done one like this. What do? Yep. Factor by grouping because you've got 4 terms, right? You split it after the second term. So here. Okay. From the first part, what can I factor out? Cosecant squared x, and I get cotangent squared x plus 2. Minus, what do I factor out here? Nothing, just a minus. So I get cotangent squared x plus 2. They're the same. I know, it's like black magic. So write the terms that are the same. Cotangent squared x plus 2. And then what do I have left? Cosecant squared x minus 1. Right? Because this is like a minus 1 equal to 0. Okay, so here, cotangent squared x plus 2 equal to 0. Cotangent squared x is equal to negative 2. Yeah? Is that even possible? Can you square something and get a negative? No, but suppose you're so wrapped up because this is so much fun and you're like, okay, it's a cotangent square. Let's take a square root. Let's take a square root. Now you have square root of negative 2, which is no good. So that's no solution from that part. Okay? Because you can't have cotangent equal to 2i, right? Yeah. So here I have cosecant squared x minus 1 equals 0. Cosecant squared x equals 1. Take a square root, and I get cosecant x equals plus or minus 1. So, where is cosecant equal to? Cosecant is like what? Sine. So where is sine equal to 1? Pi over 2 and 3 pi over 2, because we're going from 0 to 2 pi. Okay, and with that, we'll stop here and I can modify the homework for you.